Hello students, in today's session we are going to start a new topic, that is work. So our today's topic is work. What is work? So before going to the definition of work, let us see how we calculate work. And when we say work is done by the force, after this we can see the definition of the work. So for this, I'll show you a small example. What is the small example here we are considering? We consider a smooth horizontal surface on which a block is there of mass m. And this block is at a position A. On this block, what I am doing is I am applying some force F. Some force I am applying. Then what we observe is, because the surface is smooth, we observe that this block from the position A, now it has moved to the position B. Same block of mass m. And if you calculate what is the displacement from A to B, we get the displacement as S. So we say in this situation, we say that the work is done by the force. Why? Because the block has been displaced from the position A to the position B. And in this situation, how we calculate, come to the question of calculation of work, how we calculate the work done by this force. So we calculate the work done by the force as, this is work done by force. That is, W is equals to the product of force and displacement. The product of force and the displacement, we call it as work. But here we have one restriction. What is that restriction? You should understand. Here, the restriction here is to use this formula. The restriction here is the force, the direction of the force and the direction of the displacement, both are same. You can see I have applied a force. I can say horizontal force, and the displacement is along the horizontal. Both are in the same direction. Then only we can use this formula, W is equals to F into S, the product of force and the displacement. Now, the question is how to calculate work when the force applied, it is not exactly in the same direction of the displacement. It is inclined. It is inclined at some angle theta with the displacement in everywhere. So let us go for another situation. What is that situation? Try to see. Suppose a block is there on the horizontal surface, a block of mass m, and this block of mass m is at the point A. Now, what I am doing is I am not applying any horizontal force. So what I am doing, I am applying some inclined force, inclined like this. And this inclined force is inclined at an angle theta, at an angle theta with the horizontal, at an angle theta with the horizontal. So if you apply this much force, then body has a displacement from point A to the point B. So how much force we are applying? That is in vector form I am considering now. How much force we are applying? That is just theta. Oh, sorry, how much force we are applying? F inclined at an angle theta. So how much is the displacement in the horizontal direction? So let us see. This displacement in the horizontal direction is S. So my question is, can we take just F into S? No, that is not possible. The reason here is this F is in this direction and the displacement is in this direction. So we cannot just apply the case what we have applied just now, that is force into displacement. So here what we have to do, we have to take the same concept. The base or the fundamental of the work done is the same. That is the force and to displacement, force into displacement, and both are in the same direction. So here also what I do here is, this is F and this is what I am having here, angle theta. So what I do, I resolve this force into two components. This is F. So this will be F cos theta. In this direction, it will be F cos theta. And in this direction, if you see this one, this will be F sin theta. The components I'm taking. So this F cos theta is in the direction of the displacement, or I can say the displacement is in the direction of the component of the force. This is not the force. Try to understand, F cos theta is not the force. F cos theta is the component of the force. So how to go with the definition of the work? Work is, again, work is what? That is F cos theta, because this much is the force here. Here F was the force, and here it is F cos theta is the force. So I take F cos theta into S. That is the displacement. Now, what I do here is, this is Fs cos theta. I'm writing in order, Fs cos theta. And we know the dot product. We know the scalar product. What is the scalar product? A dot B, that is vector A dot vector B, is equals to AB cos theta. So in the same way, it is Fs cos theta. So I can write this as F dot S. F dot S. That means work done is the scalar product of force vector and the displacement vector. So how we are going to define, how we are going to frame the definition of work here? We can say that the work is work done by the force. Of course, it is the work done by the force is defined as the product of the component of the force. Try to understand, it's the product of the component of the force and the displacement. So now you can see the definition of the work on the board. So what is the definition here? Let us see. See, this is the work. What is the work here? You can see the work done by the force is defined as the product of the component of the force. You can see it is the product. Product means multiplication. Product of component of the force. It is not just the force, the component of the force, I say. So this is what I can say. This is a component of the force. This is the component of the force in the direction of the displacement. Yes, it is. I have resolved this into F cos theta and F sin theta. So which component I have to take in the displacement, direction of the displacement? So it is the product of the component of the force in the direction of the displacement and the magnitude of the displacement. This is the magnitude of the displacement. And from the definition itself, we are coming to a conclusion that it is the dot product. It is the dot product of force vector and the displacement vector. I hope the concept is clear. Now, students, come to the types of work. Like we have seen what is work, but there are three types of works what we can expect. The first one is the positive work. The second one is the negative work. And the third one, we call it as a zero work. So what is this positive work? What is the negative work? What is the zero work? Let us go by one. So the first one, what we are discussing is a positive work. So the work done by the force is said to be positive if the angle theta is acute. Try to understand. If the angle theta is acute, that means the angle between the force and the displacement, if it is acute means less than 90, then the work we get as positive. I'll give you the example. So this condition, the first what I can write here, if this work is positive, that is the condition, that is theta must be less than 90. If theta is less than 90, then we say the work done by the force is positive. Why? What is the reason? Theta less than 90 means if I take students like just you take an example where I'm taking theta value as 45. What is the value for cos 45? It is 1 by root 2. Cos 30, it is just root 3 by 2. Cos 60, it is 1 by 2. So if the value for theta, if it is less than 90, then cos values we are getting positive. So therefore work done is positive. So here this is theta is less than, that imply cos theta, the value for cos theta is always positive and we get positive work. positive work, as we have this condition work done is equals to Fs cos theta. So when this cos theta is positive, work is positive. And of course, when cos theta is negative, that is for more than 90, I can say. If you take an example where we go for cos 120, it is minus 1 by 2. Cos 180, it is minus 1. That is a different situation we discussed separately. Now, when theta is less than 90, that cos theta is always positive and positive work. The reason here is as work done is equals to Fs cos theta. Now, students, the example what I can give under this situation is work done by gravitational force. Gravitational force when a body falls freely. When a body falls freely. So under this situation, if you analyze what happens here, if suppose this is the ground, and here one's body is there, and I'm leaving this body, just I'm leaving this body. So what happens, you know, the displacement, how the body is moving, that gives you the direction of the displacement, and the displacement, direction of the displacement is down. The direction of the displacement, it is down. This is the moment of the body I have shown, and here I am showing the direction of the displacement vector, it is downward. And how is the gravitational force acts? How is the gravitational force is going to act? Gravitational force always acts in the downward direction, that is toward the surface, or I can say toward the center of the earth. So when the body is freely falling, or when the body is projected upward, irrespective of the situations, always the gravitational force, that is the weight of the body, I can say, it always acts vertically downwards. So if you see here, the direction of the force vector, it is down. When they have the same direction, what is the value for theta? I say in this situation, theta is 0 degree. Theta is 0 degree. So what is the formula for work? Work is equals to Fs cos 0 degree. So this is Fs cos 0. Cos 0, it is 1, and we are getting it as Fs. Cos theta, it is 1. So cos 0 is 1. So it is 1 into something is the same thing. And you can see clearly here it is a positive value I am getting. Positive value. That means the work done is positive. I hope the concept is clear. Now let us go for positive work is over. Next, we go for negative work. The second one. So just now I said the work done is negative when the theta value is obtuse. Obtuse means more than 90. Like we say cos 120, it is minus 1 by 2. Therefore, the minus 1 by 2 into Fs, you are going to get negative value. The second one, if I say cos 180, it is minus 1. So negative values we are getting for cos. Overall, the work is affected, and it is, I can say, that is a negative work. So let us see the first point what I have written, it is greater than, less than. So it is what? यहाँ पे हम लिखेंगे, it is greater than 90. Here I have written it. So cos, when it is greater than 90, cos theta is always negative. And one condition is also there, students. Here I am saying it is less than 90. From where to where? So here we have to condition, here we have to put one condition also, that is the theta value must be in between 0 and it should be less than, it means this one, less than 90 degree. And here also, if you write in detail how I have written here, so how to write this part, the theta value, if you see, it is like this. This is the situation. We should not include 90. Here we can include 0. We should exclude 90. But here you can include 180. It is less than or equal to. Equal to means that value also you can consider, but you should not consider 90. Okay, why we should not consider 90? I think you are getting that question, so that will be clarified soon. Okay, now if it is theta is greater than 90, so cos theta is always negative, and the second part we can write here, the work done, this is what is negative. This is the point what I have written. Work done is negative. Here, what is the reason for writing this work done negative? As work done is equals to, again, the same reason, Fs cos theta. Now, what is the explanation? What is the example? The best example what I can give here is when the body is projected upwards. So when the body is projected upwards, so what happens? How is the displacement, direction of the displacement? The direction of the displacement is up. But how is the force is acting? The force, gravitational force is acting down. Let us analyze the situation. Example here. Now, suppose what I am doing, I am projecting the body up like this. So this is the situation. So displacement, direction of the displacement, if I see, it is upward. But the gravitational force, as I said, you always acts down. So here you can see the gravitational force. This is the gravitational force. Now you can see both the directions are exactly opposite to each other. One is like this, other is like this. Both are opposite. So therefore, we say the angle between them is 180 degrees. 180. So theta here I take. Theta is equals to 180 degrees. And the work done is equals to Fs cos 180. Cos 180 means it is -1. And we are getting it as minus Fs. You can see clearly it is the negative work. So this the reason why we are getting a negative work. So we have seen, students, what is the positive work, what is the negative work, what are the situations, everything we have analyzed. So we move to the next topic, that is what you call it as the zero work also. Now, students, we move to the next type of work, that is a zero work. We have seen the positive work, we have seen the negative work. Now let us go for the zero work. So when the work is said to be zero, let us see the conditions. So here, if I take the formula for work is equals to what we are having, Fs cos theta. I want to have this work to be zero. That means the first condition, if suppose F is equal to 0, that means no force is applied on the body. The no force is applied on the body. So how much is the work done? So work done is 0. Even if for the smooth surfaces, you should keep in your mind, for smooth surfaces, students, there is no force required to keep the body is in motion. Try to understand, for the smooth surface, the body will keep on continuing by itself. So even though the displacement is there, but we are not applying any force. So in that situation, what we say, when the force is 0, the work done is 0. The reason here is mathematically F is 0, 0 into something is 0. Next, the under what condition we can say, the second one, S is equals to 0. What is S? S is the displacement. In this situation, even though you are applying the force, but there is no displacement. I'll give you an example. Just you try to push the wall of your room. What happens? You can apply the force, and even though if you apply the force, will the wall move? No, the wall is not going to move. There is no displacement in the wall. You leave the example of this wall. Just go in front of a train or a truck. Just try to push it. What happens? Will it move by your force? No. That means the force is applied, but there is no displacement. Displacement is 0. When the displacement is 0, force is there. So what I say, something this is 0, 0 into something is 0. So therefore work done will be 0. So this is the first condition. This is the second condition for the work to be 0. The second and the third one and the last one, that is cos theta must be 0. Either this must be 0, force must be 0, or S must be 0, or cos theta must be 0. Even though if like we are having the force, we are having the displacement, try to understand the third and the important. Even though we have the displacement by the application of the force, but if the angle between the displacement and the force is exactly equal to 90 degree, we say the work is to be 0. Work is said to be 0. The reason here is, you can see cos theta as 0 means theta is how much? When we get cos theta as 0, so it is like cos 90 degrees. So theta is equals to 90 degrees. So when both force and the displacement are perpendicular to each other, we say there is no work. There is no work. Here n number of examples I can give. Like first example what I have taken for today's class, example 1. Suppose Earth is there and it is revolving around the sun. So there is a gravitational force between the sun and the Earth. So what I do here is I'll take an example. This is an elliptical orbit, what I am considering. This is the position of the sun as one of the foci, and this is Earth. This is Earth. Just see, this is an Earth, a planet. So there is a gravitational force between the sun and the Earth. So how it is the gravitational force? It will be line joining, along the line joining like this. The gravitational force will be like this. I'll write Fg as the gravitational force. But for a moment, what is the direction of the displacement for the Earth if it is revolving like this? So what I do, I say that the displacement is small, like here. You can say here the displacement is like this. This is the direction of the displacement, and you can see exactly what is the angle between these two. So under this situation, theta is 90. So I say work done by gravitational force, that is equals to 0. What is the reason for work done for the gravitational force to be 0? Here theta, you can see exactly it is 90. So when it is exactly 90, I take the same formula Fs cos theta. The reason I'm showing you here, W is equals to what? Fs cos theta. Theta is 90. So cos 90 is 0. 0 into something is 0. This is the explanation for this. In the same way, if you go for the electron revolving around the nucleus, these all bits are important for competitive. Remember, we never think for the work to be 0. Whenever there is a force, there is a displacement. What is our general thought is there must be some work. But students, this is a very important point. Even though the force is there, even though the displacement is there, but there is an angle, and that if there is that angle equal to exactly 90 degree, then we say the work done as 0. The second example you can see on the board. The second one, suppose this is the nucleus and the electron. Here electron is revolving around the nucleus. Now there is an electrostatic force. Here I am saying that electrostatic force between the nucleus and the electron. And how it acts? It will act along the line joining the electron and the nucleus. So this is like this, and I say the electrostatic force, I am writing it as Fe, as an electrostatic force. What is the direction for the displacement at any instant? It will be like this again. So what is the angle here? You can see the angle here also, it is 90. So theta is equals to 90. So work done is how much? Work done is 0 again. I'm not doing each and every step, just I'm writing directly. Since theta is 90, work done is 0. So when the electron is revolving, or when the electron revolves around the nucleus, how much is the work done by the electrostatic force? So you have to say that work done by the electrostatic force is always 0. Work done by the gravitational force is always 0. Now let us go for another example. Example 3. Now this example, if you are going for this example 3, what is this example? Because this is a very much familiar. You people are very much familiar with this. Let us see. Suppose I take a pendulum. This is the pendulum. Now, if I displace this pendulum from the mean position, if I leave this, then what happens, you know, for the particular angle theta, here we can resolve the weight into two components. That is what I'm doing. I'm resolving this into two components. That is mg, this is the weight, and I'm resolving this. If it is theta, this will be mg cos theta, and this will be mg sin theta. This is mg sin theta. Now, how is the tension and where is the tension here? The tension will be along the string. You can see this is the along the string. The tension will be along the string. So if I ask you, what is the work done by the tension in the string during the motion of the pendulum? Pendulum, it oscillates. So what is the work done by the tension? You can see clearly in the figure, the pendulum is oscillating like this. You can see here the pendulum is oscillating like this, and the tension is acting along the string. So what is the angle you can see here? What is the angle here? You can exactly see it is 90 degrees. So under this situation also, theta is equals to 90. So therefore, work done by the tension, it is 0. I hope it is clear. The fourth and the last. I say last but not the least. The very important example, the fourth one. The fourth one. Suppose one coolie is there, and this coolie is carrying the luggage and he is moving. Let me draw the situation. Coolie is there, and this coolie is lifting some load on his head. Now, students, when this coolie is moving from one position to another position just to have the luggage to get transported. So suppose the final position of this coolie, you can see here, this is a final position. ये final position है बेटा coolie की. He has carried the load from one position to another position. Let us see, this is A and this is B. So there is a work done against him, work done by him against the gravitational force. He is lifting and he is moving. Work done by him against the gravitational force. So my question is, how is the displacement for this coolie? How it is moving? How he is moving बेटा? यहाँ पे कैसा मूव हो रहा है ये coolie? तो आप बताएंगे it is move. He is moving like this. इस तरह से coolie move हुआ, so direction of the displacement is like this. So work done by him against the gravitational force. Against, I'm not just saying work done by him. I'm saying that work done by him against the gravitational force. So how is the gravitational force? Gravitational force will act like this. Complete gravitational force always acts down, vertically downward, irrespective of the moment of the body. So here is the gravitational force, and you can see clearly, आप देखकर बता सकते हैं कि भाई this is the displacement and the direction for the force. तो कितना एंगल है ये दोनों के बीच में? The angle आप, you can see this is exactly 90. So when this is 90, theta is 90, so work done by the coolie against the gravitational force. Try to understand and try to stress on my words. Work done by the coolie against the gravitational force is 0. I hope the concept is clear. अब ये मत समझना है कि भाई work done by the coolie is 0, तो सर पढ़ा दिए आज कि भाई वर्क डन बाय द कूली इज 0, अब हम पूरा काम कराएंगे कूली से, और लास्ट में बोलेंगे देखिए हमारे सर बोले फोर्थ कंडीशन में बताए थे कि भाई ऐसा कूली लेके गया और ऐसा रखे तो आपका जो है ना फोर्स इनटू डिस्प्लेसमेंट, दिस इज द वर्क डन, और 90 बनाए आप 0, आप कुछ भी काम नहीं करे, इस वास्ते नो मनी, पैसे हम नहीं देंगे। ऐसा अगर आप बोलेंगे तो ही डजंट नो ऑल दिस लॉजिक्स, राइट? उन्हें क्या करता मालूम है, वर्क डन बाय द कूली अगेंस्ट द ग्रेविटेशनल फोर्स तो 0 हो रहा, लेकिन वर्क डन बाय मी ऑन यू हाउ मच इट विल बी, ही विल शो यू देन एंड देयर इटसेल्फ। ऐसा नहीं बोलना है, जस्ट इज अ फिजिकल कॉन्सेप्ट, दैट्स व्हाई आई एम डिस्कसिंग। ओके, थैंक यू। ठीक है, नाउ स्टूडेंट्स लेट अस मूव with the problems itself. So the first problem under the concept of work, it is there on the board. The first problem is a rigid body moves a distance of 10 meters. Don't see the length of the question, just see what the question says. A rigid body moves a distance of 10 meters. Here, I would like to remove a confusion, small confusion. Sometimes we say displacement, sometimes we say distance. What is this? Remember, students, distance is a scalar quantity, displacement is a vector quantity. Both are different, but under one situation, both are same, that whenever the body is moving along a straight line. Whenever the body moves along a straight line, always distance and displacement both are same. So that's why we are saying a rigid body moves a distance of 10 meters along a straight line under the action of a force of how much? Here it is, the force is given as 5 Newton. So here I would like to stress on this 5 Newton, and the second one is what I can say, this is what, 10 meters. Then if the work done by the force on the body is how much? 25 joule. Then we have to find the angle which the force makes with the direction of the motion of the body. Just we have to find the angle. So let us go with this. So this is the displacement. Given data I am writing. Force, how much? The force acting, it is 5 Newton, and the work done, it is 25 joule. Okay, next we have to find what is this theta, how much is the angle theta, that is our question. So under this situation, if I take the work done is equals to what? Fs cos theta. Today we have discussed only this one, right? So W is equals to Fs cos theta. What is this W? W is 25. F, what is F? It is 5. S is 10. Cos theta. So this is 25, that is equals to 50, and this is cos theta. Now student, this cos theta, if you're looking for the cos theta, then this is what, 25 divided by 50. I'm taking this 50 in the denominator, so it becomes 25 by 50. 25 one times, 25 two times. So this cos theta is equal to 1 by 2. So when 1 by 2 comes under cosine function, it is at 60 degrees. So therefore, what we can write here, this is cos theta is equals to cos 60, and this theta gets cancelled. Theta is equals, sorry, cos gets cancelled, and here theta is equals to 60 degree. This is the answer. Hope you have understood. Again, I say, don't go with the length of the question. Try to understand the concept. The problems will be easy for you. Now, students, let us move with the next problem. What is this next problem says is, find the work done in moving a 50 kg block through a horizontal distance of 10 meters. So here also, if you see how much is the displacement or a distance, it is 10 meter, and how much is the force, we can see the force is 100 Newton, and the angle is also given as 60 degree. We need not to do anything with the mass of the object, because the force applied is how much, and how much is the displacement, what is the angle. All these three quantities are more important in order to calculate the work done. So here, what I do here is, work done is equals to, again, I apply the concept Fs cos theta. So what is the force here? Directly I'm writing this is 100, and displacement is 10 meters, cos 60. So this is 1000 into cos 60, it is 1 by 2, and this, if you cancel, exactly it is 500 times, so it is what, 500 joule. I hope you have understood it. My students, again we are seeing the next problem. We can see the next problem on the board. This is the next problem. See what the next problem says. A body which is constant for move along y direction is acted upon by a force. Here the force is given. I'll write the force. It is how much? F is equals to, that is F bar is equals to minus 2i plus 15j plus 6k Newton. Here the units are mentioned as Newton. The work done by this force in displacing the body by 10 meter along the y-axis is. Here they have not mentioned the displacement directly. They want to test the student whether they have the knowledge of vectors or not. So here you can see the work done by this force in displacing a body. It's 10 meter along y-axis. So 10 meters along y-axis. So I'm writing the displacement vector as, this is 10 meter, but y-axis, you should know, students, for x-axis we take a unit vector I, for y-axis we take a unit vector j, and for the z-axis we take a unit vector k. So here it is, the body is moving 10 meters along y-axis, so therefore I have to write here 10j. I hope it is clear. 10j, why I am writing, because the body have the motion along the y-axis. So here what I can do, I have to calculate the work. So basic definition, that is Fs cos theta, but the same thing can be written as F bar dot S bar. The dot product also, we can have the work done as the dot product of the force vector and the displacement vector. So dot product we have to find. F, what is F here? It is minus 2i plus 15j and plus 6k. This is the dot. What is here? It is, student, just we have here 10j. We don't have any I, we don't have any k. So here, if I just multiply the coefficients here, like how we find the scalar product. Here the coefficient of I here, it is minus 2. And here we don't have any item, so it is 0 plus always. Then here it is coefficient of j, it is 15. And here the coefficient of j is 10. And plus coefficient of k here, it is 6. Coefficient of k, we don't have any k, so it is 0. So therefore 6 into 0. Now this is 0 plus 150 plus 0. So answer is 150 joule. So this is the answer for this particular problem, for 150 joule.